Hey everyone, a very happy Tuesday and welcome back. Welcome back to our Arm Tech Talk series. This is the place for the latest and greatest trends, technologies, and best practices from Arm and our ecosystem partners. It's my favorite part of the week hosting one of these, and today is no exception. We've got Blackberry QNX talking today about how you can streamline embedded development with Arm-based Graviton on Amazon EC2 and Blackberry QNX, and all about their QNX Accelerate tool. So really excited about today's tech talk. Before we do jump in with the content for today, and I'm sure you're really excited to hear from Chris and the team at Blackberry QNX, if you've attended one of these before, you know there's a couple of housekeeping items I normally go through, so let's just get through those as quick as we can. So, Chris, if you wouldn't mind heading to the next slide, please, that would be awesome. If you want to get involved in the conversation today, please get connected with us on Twitter or LinkedIn or any other social media platform. I should say X rather than Twitter, sorry. So you're using the hashtag ArmTechTalks and on Arm and making sure you tag us. All 80 plus tech talks are available on demand. So just head to youtube.com/arm. There's a dedicated playlist as well. So if you missed last week's tech talk, which was from Sensory, all about voice AI in automotive, a really great tech talk, that one, just catch it on YouTube under the playlist. And all of our upcoming talks are always made available on arm.com/tech talks as well. So make sure you don't miss any of those and sign up for those as soon as they go live. If you want a little sneak peek, let's head to the next slide and have a look at the upcoming table of tech talks that we have coming up. So next week, we're going to hear from Open Synergy about how you can accelerate your automotive development cycle with their lab and their technology that they have. And we're also then going to hear the week after from AWS. So we're going to talk about the software-defined vehicle. So a bit of an automotive theme here, you can see. So if you like what you see today and you want to attend any of those talks, the Open Synergy one is live already, and the AWS one should be live very, very shortly. In fact, by the time this tech talk is finished. So do make sure you register for those if you're interested. Let's, of course, though, get to today's topic, and we're going to hear from Chris, who's got a nice speaker bio and a photo on the next slide. And actually, let's get you off mute and get your camera up, Chris, as well, ready to talk. Before I hand over to you, though, I just want to introduce Chris briefly as the Senior Technical Product Manager from Blackberry QNX. He'll tell you a bit about himself shortly, and we'll take it away with today's talk. Before I hand over to him, though, please do get all of your questions in at any time in the talk using the Zoom Q&A menu box in the menu bar at the bottom. And we'll get to those at the end. That's enough from me. Chris, thanks so much for joining us today for today's Arm Tech Talk. Please take it away.
Thanks, Tobias. Thank you for having me here today. I'm very excited to be presenting to you about our QNX Accelerate product. Now, before I do start, I want to tell you a little bit about myself. So, as Tobias said, I'm a Senior Technical Product Manager here at Blackberry QNX. My focus really is on the cloudification of our QNX foundational software. And the focus really is on reducing developer friction for our customers and allowing them to realize more efficiencies in their development process by when they're using our products. Now, I originally have a background in aerospace and defense, where I worked on various different projects. This is including quantum key encryption, submarine acoustic systems, helicopter data management systems, and so forth. And one of the, I guess, common trends, so to speak, which funny enough applies to also, embedded development, is the fact that, they're reliant on specialized hardware. And when you're running a project, you usually have to start right away before you even get your hands on that hardware. So today we're going to talk about how we could actually streamline your embedded development, your embedded software development while you wait for that hardware. So with that, let me just jump right into really what we're going to be talking about. And that is the fact that, embedded engineers are too reliant on specialized hardware. This specialized hardware is really important for your entire project, right? It's important for your development. It's important for your debugging. It's important for your integration efforts, testing, and so forth and so forth. But the problem is that this hardware tends to be expensive and scarce and could take a very long time to arrive. And when it finally does arrive, it could be complicated to set up. Now, this problem was was really evident during COVID, right? Where a lot of people, there was a lot of supply chain issues. You couldn't get your hands on this hardware. And even though, COVID is over, we still see this problem today. And one of the things that this causes is it really does get your project and pushes things out. So what ends up happening is embedded developers end up going ahead and starting with their project anyway, without having the hardware in hand. And this really adds risk to your project in the sense that, you have to use alternative solutions to try to develop and test your product, which is not representative of your environment and therefore could increase the risk of having to redo your work in the future. Once you finally get the hardware and then you launch it on there and then you find, oh, nothing works, and then you have to start from scratch. The other issue this hardware dependence causes for embedded developers is scalability issues. So you might start your project today thinking, oh, I only need 40 boards. So you go and budget for 40 boards, you go and purchase the 40 boards. And while you're waiting for those 40 boards, you realize, oh, I need to actually purchase another 60. Well, now you have to add more money to the bucket. You have to now wait longer for the other 60 boards to arrive. And when they finally do arrive, you still have to go and set it up. So it really restrains your ability to dynamically shift your development with your project needs. And because of the complexity of setup, onboarding new team members is hard. Usually these boards are sitting on your desk, right? So if you need to have a more globally distributed team, what do? You're gonna buy the board and ship it over to your developers somewhere in another continent, or do you try to hire people in-house in one location so that way all the boards can stay co-located with you? Really, what becomes the solution here? And lastly, but most importantly, I think what dependence on hardware really restrains embedded software developers with is the ability to adopt more modern development methodologies, such as test-driven development, integration to CI/CD, and being more agile and flexible with how you do your work. Now, of course, embedded developers try to fall back on a traditional solution, which is just to repurpose hardware. So, you've done multiple projects in the past, so you have hardware lying around, and you try to get your hands on hardware that, that's no longer being used. So you end up using those in the meantime while you wait for your hardware. Sometimes this hardware is hooked up into a lab where, people can remotely access it, but it still doesn't solve the problem of scalability. So sure, you might have some hardware lying around, but what ends up happening is when you need 100 of these all at once, you still have to compete with other projects trying to reserve the hardware board, and you're still kind of bottlenecked into a limited set of boards available to you. Now, the other solution that embedded software developers end up falling back on is using emulators. Now, what emulators do is they tend to mimic both the software and hardware behaviors of your target board using your existing development platform. So in this case, you're usually running an x86 on your laptop, and you launch your emulator on your laptop and you start working with it. The problem with that is that emulators end up using binary translation, which doesn't necessarily represent accurately how the code gets executed on the target board, because you're moving from one instruction set to a different instruction set. And on top of that, it adds a lot of overhead in trying to actually match or trying to replicate what your intended target hardware board does. So you could end up with maybe some behaviors that are unexpected, erroneous, or you just end up getting a very slow performing computation for when you're testing your software. So this is where our new QNX Accelerate solution comes in. So what we've done is we've taken our foundational software, our famous QNX real-time operating system, and our QNX Safety OS, and we put them in the cloud to run natively on AWS Graviton 2 hardware. And what this does, because it's running natively on ARM hardware, is you actually get binary parity with your ARM architecture executables. So what that means is you're getting one-to-one execution, exact instruction set that you've programmed it for, with the ability to, of course, scale as much as you want in the cloud, and without having any of the drawbacks that you normally have with physical hardware or emulators. So you get both the proper execution instruction set, the scalability, and no performance overhead when you're running our RTOS in the cloud. Now, you do get certain benefits with this by using our QNX Accelerate products. So the first one is, of course, high availability. So you could actually launch as many instances as you want in the cloud. So you could, if you needed 40 today or 60 tomorrow, you could do that. If you needed 100, 200, 1,000, you could launch it. You could launch those as well. Moreover, you could actually not just launch the number of instances, but you could also change the configuration of the instance. So if you need to target, a 2-core system that you're developing for versus an 8-core system for a different project, you could also configure those appropriately in the cloud. So you could actually do this for multiple projects with high availability, so no one has to compete for hardware or try to provision or budget for specific type of hardware. You can also do early testing. So as I said, this is running with binary parity. So what you could do is actually de-risk your code early on by actually running tests in the cloud and validating that things are being executed properly and reducing the amount of churn that you would expect in the future when you eventually get hardware boards and do your qualification efforts on real target. So what this does is it really does increase your performance in development and testing, reducing the amount of time that you need to spend, reconfiguring hardware, flashing it on there, and trying to debug why it's not working. Because this is running in the cloud, it very easily integrates with CI/CD pipelines that's running anywhere. You could, if it's your CI/CD pipeline running on premises, running in the cloud with different providers, it seamlessly integrates, letting you to automate your development, scale up as you need, and really provision any test environment that you want for your virtual targets in the cloud. We've seen this with some of our customers. They actually do rapid prototyping as well with this product. So what they do is before they even commit to hardware, or if they're maybe submitting an RFQ, they'll go and actually prototype things and use our cloud virtual target to actually test out the software that they want to actually develop for a new project or sell to a customer. So they'll actually use this before they even get their hands on hardware or even commit to a project by doing it all in the cloud in a Arm-based virtual environment. And lastly, of course, it makes collaboration so much easier. So what you could actually do is you could create a golden image, share that golden image with the rest of your team, so that way you have a common development environment, or you could even have people integrate and access a single instance and collaborate together in a single environment. This is true of your in-house teammates, or you could even do it with your partners. This is something that we do today when we try to help debug our customers who are using this product today. Sometimes they'll just give us access, we'll log right in, and we'll start debugging with them live using this virtual target. So you might ask, what products does QNX Accelerate currently have? We actually have 2 currently available on the marketplace, which is Neutrino RTOS 7.1 and our QNX OS for Safety 2.2.3 running in the cloud today. And we actually have early access availability for our Hypervisor 2.2 and our Hypervisor for Safety as well. So you can start today using the QNX Accelerate product to start, improving the efficiencies of your development cycle. Now, these, as I said, this is really for ARM-based development. So for customers who are using ARM as their target boards and need that binary parity, you could use this in the cloud as much as you want, on demand, to be very dynamic with your project development. It's very easy to access. You could just go to the AWS Marketplace, search for QNX, and then you just, at the click of a button, get started and start running with it. Now, just as a maybe little in-depth explanation as to how this works, because some people ask, is this a different product than what we actually sell with our SDP? No, this is actually one for one what our OS is. So all we did, what the QNX AMI is just some foundational pieces that make the target system work in the cloud. So that includes our kernel, serial, file system, networking, debugging, and so forth. We package that up into what's called an Amazon machine image, and then we post it on the marketplace for you to be able to use it. Now, you could, of course, overload the software stacks that we've put in there, except, of course, the kernel, or you could even add to it and build on top of it, adding your apps, your own libraries, your own drivers, and so forth. And then what you do is you could actually save that new image that you've created. So once you add all your stuff, you just hit create image, and you create what's called a QNX derivative AMI. And that's the one you basically create as a golden image, and you continue to work with it and, share it with your teammates and keep developing on top of it. And you could, of course, use the SLM to basically manage the startup to make sure things boot up as you expect it on the target board and so forth. Now, we did provide some additional features so that we don't just have to use a terminal to interact with our QNX product. So we provided actually a software GPU, a software audio, and WebRTC. And what this actually lets you do is develop HMI and audio applications as well, and be able to interact with the instance in more than just command line. So you could, if you wanted to, say, develop a GUI for your medical application, or maybe develop a cluster for your automotive, you could do that with this product. And we actually use WebRTC, which allows you to just basically log in through a web browser and you get the graphics right there. So as long as you're using, say, something like Chrome that has WebRTC automatically enabled by default, you basically just ping the IP address and you get your graphics, you get your audio. You could actually send audio into the instance, receive audio back. You could use keyboard, mouse, you could use touchscreen. It's very interactive. So we made it easy for you to actually do development with it. Now, I do want to dive in and kind of give you some hands-on use cases of how to use the product. So we're going to actually do some demos. So the first demo is very simple. It's how easy it is to access this from the marketplace. So I'll show you how to select it, launch it, connect it to your IDE, push a simple hello application, and then save it and share that golden image with someone else. The next demo that I'll do is actually demonstrate how you could automate your development and testing using something like Jenkins and this virtual target. So what I'll actually do is I'll launch a Jenkins orchestrator, have a simple pipeline written up, which will then automatically kick off every time I push new code to my repo, which will then launch a virtual target, test it, and then terminate. And then lastly, I'll also show how you could use our QNX hypervisor in the cloud. Now, just as a quick, I guess, info for the hypervisor. So we actually use Vert.io as our standard to make the software agnostic between the cloud and your end target system. So your guest will essentially have front-end Vert.io drivers, and we'll provide the back-end Vert.io drivers, which lets you effectively, whatever you develop in the cloud, you just basically cut and paste straight into your new SoC in the target without having to change anything. So I'll demonstrate that as well. Now, before I do jump into demos, I do want to basically quickly just talk about some of the trends we're seeing about cloud. So what we're seeing right now in the embedded market is that there's a lot of consolidation happening. So we're going from multiple ECUs into really singular high-performance compute SoCs. And on top of that, we're using virtualization technology to actually share mixed criticality applications. So this is safety critical, non-safety critical, real-time requirements, non-real-time requirements, and so forth. And this is kind of where cloud comes in. Because what's happening is you're starting to see really a mirroring between the cloud architecture and the embedded architecture, where you end up having, say, the device infrastructure at the bottom. For embedded, you have sensors, actuators, displays. For the cloud, you'll have hardware in the loop that you could connect into your data centers. Then the next layer up, you have your high performance compute systems with all the peripherals. And then in the data center, you have your high performance compute servers along with its peripherals, such as network cards and so forth. And then on top of that, you have your software stacks, which are now beginning to abstract away the specifics of the SoC on which you're running. And this is kind of where the future is moving, where as these two sides begin to blend, you're actually going to be able to do a lot more between the cloud and your embedded device. Right now, we're starting off with a baby step of saying we're going to streamline your development. You're going to be able to do essentially digital twinning in the cloud, do your development testing there, and then validate on the hardware. But a couple of years into the future, you'll actually be able to do a lot more. You'll be able to do OTA from the cloud straight to your embedded device. You'll be able to do software distribution, where your applications are more fluid between your embedded device and your cloud. You'll be able to do monitoring, where you collect data from the embedded device, process it in the cloud, and push some actions to your embedded device. And this is kind of why the cloud is so important today. And we highly recommend that you get started today using QNX Accelerate, because it is just one step in many to getting to a more advanced software-defined vehicle or device that you're developing. So with that, let's now jump into some demos. So I will just open up my AWS console here. So right now I'm logged into AWS, and for the sake of time, I already have a few things pre-configured. So I have my key pairs, my network card, my security groups, and so forth. So let's start by launching just QNX. So if I type in here, QNX, hit search, and go to the AWS Marketplace, you'll see that, Neutrino RTOS will show up. So all I'll do is we'll select that, hit continue, and then we're just going to launch an instance. Now for this purpose, I'll just say Arm demo. Here you could pick any configuration you want. You want 2-core systems, you want 4-core, 8-core, and so forth. I'll just stick to the standard 4-core system that's recommended. I'll choose my key pair, my security group. Now this security group is set up such that it will allow my IP address as well as certain ports to allow my IDE to connect and so forth. So you will select your own security group based on your company's policies. There, now we're launched. So we'll go to our instances, and you'll see that I've now launched my ARM demo. So what we'll do here is we'll grab the IP address, and we'll simply SSH into it. So we'll log in as root. And as you can see, if I type in uname-a, you'll see that we're running on the AWS Graviton 2 on the T4G X Large for ARM architecture, running the 7.1 OS of QNX. Now, the first thing I'll do is I'll just see what kind of processes are running, just to confirm that, I don't have QCon running, because we will need QCon to be able to connect via our IDE. So what I'll do is I'll now just type in QCon, and then I'll go to my IDE, go to my target navigator, and just simply say new QNX target. Oh, I will need my IP address. Let's grab that. And now it's connected. So what I could do here is when I of course can do debugging. I could do system profiling and so forth all through the IDE, just as if it was a real target board sitting on your desk. Well, what I'm going to do here is I'm just going to transfer over a simple hello world application. So I'm just going to open up the temp folder, confirm that there's no hello world application here. And we could actually confirm that here as well. So if I do an ls temp, you'll see that there is no hello world application. So we'll go back to the IDE and I'll just grab my hello world and drop it in. There, now it's in. So if I do that again, we will see that the hello world is there. And if I run it, I'll say demo from the cloud for ARM. And there we go. We have a working application running in the cloud. Now, if I was to remove this, I could even do debug. So let me just validate that it's gone. Okay, we could actually debug from here as well. So we could go ahead and debug. Let's see. So it's targeting my instance in the cloud. It will upload it to the temp folder. I will pass in no arguments so that way it could fail. And then we will sorry, this thing is in the way. Sorry, the presentation thing is in the way right now. So let me see if I can move that out of the way. Okay, needless to say, we'll leave it at that, but you could debug. For the sake of time, we'll move on. So you could also debug, and you'll be able to see, all the instruction sets that's being used in the ARM architecture, see all the registers and so forth. So let's now say you want to save this golden image and share it with your customer, right? Or your partner or your team members, because we now have, say, hello world in there. So let's just actually move that back in and save it. So let's just drop that back in. Validate it's there. Okay, so what we'll do is we'll actually now just simply save it. So what you do is when you have your now image that you've configured with all your software stack and so forth, you just simply go actions, images, and create image. And you give this, a name, say golden image, a description and so forth. And then you just simply save it. And if you were to go under your AMIs and owned by me, you will find that the image is being created. And right now it's just pending the creation. And once it's created, you'll be able to actually go under permissions here and then select the accounts that you want to share it with. So say you have a partner, you could go and share it with them there. Now, the next demo I wanted to show you is actually how to integrate this into a CI/CD pipeline. So what we could do is I have my CI/CD pipeline demo here. So I'll launch that. I'll select a specific configuration, use my key pair. This time I'll select my Jenkins group, my security group. And here you'll see that I actually have two disks. One is the original disk, and then one is for my tools, my build tools that I've set up. And we're going to launch that. When I go back to my instances, I should see my Jenkins show up. See, do you see the difference between QNX launching, how fast it did, versus another operating system? There we go. We'll grab the IP address there, and then we'll SSH into that one. Now this one is EC2 user, so we'll SSH there. And we're going to start up Jenkins. So now while we do that, we will also navigate to our Jenkins. The beauty of using operating systems other than QNX. Okay, so now it's up and running. So let's just make sure that is correct. Okay, it's running. Now, for the sake of time, I'll also just quickly begin the launch of the other demo, which is the hypervisor in the cloud. So we will launch the hypervisor. And while Jenkins is still trying to load, we will jump to the hypervisor demo. So in this case, I'm actually going to use the hypervisor demo just to show that software GPU and software audio that I was talking about. So we're going to quickly do a PID in. As you can see, we already have an Android guest running, and we have our WebRTC running, but the IP address is actually set to 00. So let's just quickly slay that and start it up with the right IP address. I think my internet connection something might be wrong with my internet connection, and that's why things are acting up a little. Luckily, okay, I actually have a demo that I had launched earlier today. So since I'm having some internet connectivity issues with, I assume it's some kind of corporate firewall that's just kicking in or something. Their IT is probably pushing an update. Here's an example of what the graphics and hypervisor look like in the cloud. So what you actually end up having is you could do, say, something like a cluster on one side, an IVI on another. We actually have simulators working where you could actually, for example, feed sensor data into it, have your navigation running, and so forth. So this is actually kind of like what you could do with QNX Accelerate. You could actually advance your development very quickly by using the cloud, where you could actually integrate your software right now in the cloud, have a developer working on say on Android, having another developer working on native applications, and so forth. Now, for the sake of time, I don't want to take up too much more from you trying to get the other demos to work. I do apologize for that. So with that, I'll actually now hand it back over to Tobias for Q&A.
No worries. Thank you, Chris. Well, look, it's like, this proves it's live. This is not coming from a pre-recorded stream in any way. So, these things happen, but, these are really, really great demos, and it's great you got to show bits and pieces off as part of the solution you're offering. So, really great tech talk, and now it's time for questions. So we'd love to hear from you as the audience. We've already got some coming in. I've got a couple of questions, but let's get those questions coming in now. So, well, I'd love to touch on first the kind of peripheral support that you have. So what peripherals does your Arm-based cloud support, like GPU, USB, Bluetooth, Wi-Fi, etc.? Could you go into a bit more detail on that?
For sure. So as you saw, we actually have a VirtIO layer between the host machine and our guest machine. So in terms of peripheral support for at least the guest machine, we actually do have things like VirtIO GPU, we have VirtIO block, VirtIO file system, VirtIO socket, networking, console, watchdog, and so forth. So all that is accessible to the guest. So that actually lets you do your development in the guest, being able to basically cut and paste it down to your SoC. Now, we do have partners who provide simulated data buses to be able to feed into your guest. And that's kind of where you could actually do a lot more advancements. We actually just worked with a partner recently that integrated our partner's simulators into that to feed in, say, CAN bus data, feed in USB, and so forth.
Awesome. Thank you for that. And obviously you showed off there an automotive kind of focus and automotive demo. Is it the product limited to that automotive customer base, or could it be available to customers in any sector?
So great question. So it's not by any means limited to automotive. So customers in the industrial sector, customers in the medical sector, customers really from anywhere that are developing for ARM-based systems can actually use this product today. And we actually do have customers who are not automotive who are reaching out, asking for the cloud solution, because it's kind of opened a new era in terms of what they could do, where it's not just now isolated to an embedded device. It actually has applications on data centers as well.
Awesome. Thank you for that. And now let's get to some of the audience questions, and actually kind of following on from the sort of support of peripherals and other bits and pieces. Someone's asked, and by the way, folks asking the questions, if you see one you like, just hit the thumbs up and I'll get to those ones first, at the most upvotes. So questions come in about, with QNX supported on AWS Graviton 2, does this mean QNX supports UEFI and ACPI firmware interfaces?
The answer simply is yes, we do.
Awesome. There you go. That's a nice, easy question. Simple answer. So let's have a look at the next one on the list. What other AWS automotive solutions have been ported and tested on the platform, such as Greengrass?
So believe it or not, we've ported these over before in the past. Now we're actually working with AWS as a partner in terms of determining which kind of solutions are best to be ported over kind of identifying the use cases and how we should apply them. Now, I should specify that, we do have another solution called Ivy, for example, that complements AWS solutions for IoT devices. So that's also a complementary product that we provide. I can't really speak to it. I'd have to get the product manager that's responsible for that.
No worries. A good one to follow up with for sure. If you want to follow up more with that other team. So does this come with any preferred container orchestration, or do we have to deploy solutions to the base image?
So good question. Now, I know, and usually in my webinars, I like to tease things, so I don't want to reveal too much. But at the current moment, you deploy them to the host. But let's just say in the future, there might be the option.
That's not much of a tease. That's not much of a hint. So there you go.
I can't disclose what we're working on.
No, exactly. No, that's a good little teaser for focus on the call for sure. So you hear it here. So another question's come in about for the QNX Accelerate. Sorry, actually, let's jump to the top one. Sorry, from Stefano. Can you talk a bit more about the role of VirtIO and what's the support of VirtIO devices with the QNX hypervisor from Stefano?
The role of VirtIO?
Yes.
So if you think back to the image I showed in terms of how cloud and the embedded device are actually starting to mirror each other. So really what we're using VirtIO for is to actually create that abstraction layer between the SoC and the guest, right? So the idea here is really that for our customers, we want to make it very easy for you to basically develop in the cloud and then plop it into an SoC, right? So you as a developer or customer, you put in the front end drivers for VirtIO in your guest, so that'd be Linux, Android, you name it. And then we handle the back end drivers. And the back end drivers are really the ones that then do the hardware specific details. So we currently as QNX, we of course support multiple pieces of SoCs, various ones, and we try to take that complexity away from the customer. So we say, here you go, you develop with VirtIO, you target a single type of driver, right? And we'll deal with the back end with the specific SoC for you.
Awesome, thank you. And then a question's come in, and I want to make sure I get this right from Ramya. How can we connect to existing hardware? I think they might mean existing hardware on this. So I don't know if there's anything particularly you want to ask for or answer further on that, Chris, on your side, how you can connect to existing hardware.
So if I understand the question correctly, and I do apologize if I misinterpreted it, but right now, so when you have a physical piece of hardware sitting on your desk, you could connect to it via serial or via IP address, right? What I demonstrated today is I connected over IP, right, using QCon. Now, What I didn't show is actually you could connect over virtual serial also in the cloud. So what you could actually do in the AWS console is navigate to connect, and then you hit serial, and you could actually connect via serial that way. So you could actually get all the data dump, all the output over serial and so forth. So you do actually have multiple options, and it behaves exactly really like a target board sitting on your desk.
Awesome, thank you. See, if there's further questions off the back of that, absolutely do jump in. We've definitely got time for that, but I think that's what I interpreted as well. So yeah, that's really, really good. And the top voted question now is from Peter that's come in. As I understand, the solution is a QNX OS running on virtualized hardware, still fast, and the GPU is software-based. This is slow. I'm a bit concerned about performance. Can we just use a VM for that in local development machines? Could you tell us more?
So good question. So I actually ran this between the emulation on my desk versus the cloud native solution. This is actually another kind of maybe distinguishing factor between running emulated or running natively in the cloud. I get 25x the performance running natively in the cloud for the exact same configuration as a local emulation. So that's really a big difference between when you use it in the cloud and in an emulation. Now, I just do want to specify that. So the software GPU is just a driver, right? So what ends up happening is you could develop your application doing all your graphics and HMI development. And when you come to port it over to your actual physical device, all you have to do is just replace that driver with your hardware-specific driver. So everything behaves the same, sorry. And what QNX does is we actually have a framework with which you interact with. So you're actually interacting with the screen framework, not directly with the GPU, and then that interacts with the driver, right? So your application will actually remain one-to-one between the cloud and the target.
Awesome. Thank you for that. And we've got a couple of questions here from Andy. For QX Accelerate, do we have to schedule a demo, or is it available, the demo you showed, already on the platform?
So good question. So the product itself is available to be used in the cloud. If you need specific, say, software tools, like say the graphics or audio, or say early access to the hypervisor, then you have to come and talk to us so we could provide those to you. But you could get started right away with what's on the marketplace. Now, what we've done with the marketplace solutions, we've actually kept it very bare bone. So it's what we call vanilla flavor OS. So that way you could actually build on top of it. So we didn't want to over prescribe what's in the image. We just gave you kind of the basic pieces to make it work. And then that way you could build on top of it to your desires. So if you do need any support, any specific tools and features, feel free to reach out and contact us. Absolutely
do. No, I'm sure people will do after this as well, especially with that little sneak peek teaser you hinted at. I'm sure people are like, oh, what? Telling you about this. Keep me in the loop. And then we've got a couple more minutes for questions. So last chance, last call for questions. We've had a lot come in, which is great. So if you've got any final burning questions, do get them in and we'll make sure we get to those. We've had a question here again from Andy. Can you elaborate HIL and SIL? Can we package the environment and port it onto the hardware?
Sorry, I'm not entirely familiar with what HL and, sorry, the hardware in the loop. Is that what they're talking about?
I think that's what they might be referring to. Yes.
Okay.
Hardware in the loop. Yes. There you go.
So for example, what we currently do is we support certain components like your keyboard, your mouse, your touch screen, and so forth. We're actually in the process of right now supporting things like camera in the loop to be connected. Now, some of the other devices are being virtualized. So this is where our partners come in, where they provide simulators for particular devices. But we do support our own simulators. So we do have, say, like gyroscope, accelerometers, and so forth. We have our own sensor framework that pumps in data. Customers, of course, have their own. It's really up to your discretion on what you want to use. But we're currently still working on kind of defining what other devices customers want and how they should plug into the system, whether that be pre-recorded data just feeding into the drivers, or is that actual real hardware in the loop that they want, and for what purposes. Some things do have, say, timings specifications that might not work, and that's why you actually need a simulator rather than a hardware. But we could, of course, take that offline. If they have any particular requirements, feel free to reach out.
Definitely do so. And that's the final question that's come in. So audience, oh, no, actually one has just popped in. I was about to wrap up, but of course, it's just at that moment. So Martin asks, what is the DX/GL conformance level of the VirtIO GPU?
That's a good question. I don't have it at the top of my mind right now, so it's something I would have to look up when I get back to my desk. I do apologize for that.
No worries. Well, Martin, hopefully you can connect with Chris afterwards and find out more about that. If that's definitely something of interest, I'm sure people will connect with you afterwards. What would you, in fact, just on that note, what's the best way for people to connect with yourself and Blackberry QNX after this call, if they've got questions or suggestions, ideas, or collaboration opportunities?
Yeah, for sure. So you could always reach out to us through our sales channels. So you could always contact our sales team. They'll usually always reach out to us, to myself as well, with any questions that you guys have. So that way they could pull me into any meetings and help answer any questions, provide any further demos, or even access to the products. So by all means, reach out and I look forward to it.
Please do. Fantastic. Thank you. Well, I think that is the last of the questions that's come in. Chris, do you have any final words for the audience today before we wrap up?
I just want to say thank you again for having me. It was a pleasure presenting to you all. I look forward to anyone who wants to connect with us further. And if you want to learn more about QNX Accelerate, please feel free to reach out.
Awesome. Thank you so much. And thank you so much, Chris, for an awesome presentation and great demos that you've shown off today. Audience, thank you so much for some awesome questions. We had over a dozen come in, which is just awesome. I love to see when you're engaged and really enjoy today's Tech Talk. So thank you so much for your great questions. Thanks for your participation today. And if you enjoy what you see and you like this series, which is the latest and greatest trends, technologies, and best practices from Arm and our ecosystem partners, then tune in and register for all of our upcoming Tech Talks there at the same time every week, Tuesday, 4 o'clock UK, 8 a.m. Pacific time. The recording and slides from today, as usual, will be made available as soon as we can afterwards. The recording will be available on YouTube, so you just have to go there and scrub through and find the bit that you missed out for whatever reason. Again, Chris, thanks so very much. Audience, we'll see you again same time next week where we'll hear from Open Synergy, once again on the theme of automotive software.